So in the previous video we saw that by knowing the dependencies of our different tasks as well as their durations, we could already figure out the critical path for our network. And we can also figure out then what is the time it's going to take to complete the project. In this case it was 24 days. Now let's look at how we can derive some of the other task related properties for the various tasks in our network. We know the duration already, and from that we'll be able to determine things such as the early start and early finish. Those are simply the earliest time that our project can start or the earliest time that our project can finish without affecting the other tasks in our project network. We determine that through a process that is known as the forward pass. After we do the forward pass, we can then determine the late start and the late finish. Those are simply the latest times that this particular task can start or finish without affecting the rest of our project network through a process called the backward pass. Once that backward pass is completed, we can also determine the slack or the float. So let's go ahead and look at that. What we're going to do is we're going to start out here with our project network, and we're going to assume that task A can start as early as possible, and so we're going to put 0 in for its earliest task time period. So its early start is going to be 0. We add to that 4 for the duration, and we get the early finish. You see the formula up at the top there: early start plus duration equals early finish. What we're going to do then for task B and C is we're going to carry the value of 4 into those other tasks. We're going to take the early finish from A and make that the early start for B and for C. So in B here we have 4 as our early start plus a duration of 8. That gives us 12. In C we have the 4 from A, we add to that 3, and we get 7. In D we take the 12 from the early finish of B, we take that over to the early start of D, and we add 2 to that, and we get 14. In E we take the 7 from the early finish of C, and we move it into the early start of E, add 3 to it, and we get 10. But now when we get to F, since this is a merge activity, we have 2 values from which we can choose. We can either choose the 14 from D or the 10 from E. Well, we're really dependent on D getting done here, so we're going to take the larger value. Okay, so in the forward pass, a quick and easy thing to remember is that we always take the larger number on the forward pass. So 14 plus 10 is 24. So now we've completed the early pass or the forward pass through our network, and we've determined the early start and early finish for all of our tasks. That the early finish that we derive through this calculation agrees with the information we got from our critical path about when the earliest time is that we're going to finish this project. Let's do the backward pass. The calculation here is that the late finish minus the duration equals the late start. We're going to start out with F, and we're going to put 24 into the late finish for that last task in our network. Subtract 10 from that, get 14. We're going to then carry 14 down to E, minus 3, and we get 11. We carry that 11 over to C, minus 3, and we get 8. Let's look at the top row here. If we take that 14 and put it into the late finish for D, minus 2 from that, and we get 12. Take that 12 and put it over into B, minus 8 from that, and we get 4. Once again, we have a situation. A is a burst activity, so when we come back into A for the backward pass, we find that we have the values 4 and 8 that we can use. What we're going to do on the backward pass is we're going to always take the smaller number on the backward pass. So between 8 and 4, the smaller number is 4. 4 subtract 4 is 0. So now we've completed both the forward and backward pass throughout our entire network. You want to make sure when you get back to A that your late start should be 0. Okay, so in this particular example where we have one task that starts everything out, its early start was 0. We want to make sure when we go through this network and come back again that we're back at 0 for the late start. If you end up with 15 here or something like that, well, then you've done some math error along the way. You need to go back and do it again. Now let's look at the calculation for slack. What we're going to do is simply subtract the early start from the late start. And we can do that with A, we have a slack of 0. With B, we have a slack of 0. With D, 0. And F, 0 as well. That's what we're expecting to see, because by definition those items that are on the critical path have a slack or float of 0. If you look at C, however, 8 minus 4 is 4. And on E, 11 minus 4 is 7. So in this case, C could be delayed by 4 days without impacting the rest of the project. Or E could be delayed by 4 days without impacting the rest of the project. However, we cannot delay the C by 4 days and E by 4 days together, because that would be a total of 8 days and then would in fact impact the project. Okay, so each individual task here has a slack or float of 4 days. However, this path through the network really just has a total slack of 4 days. Okay, so here we have our completed project network with all the values filled in.